Good morning. I'm going to explain you different trials we did during the LIFE project, LifeMed Green Roof, at Fondazione Minoprio, a training center near Como, in the north of Italy. The main goal of these trials is providing spread methods of selected species for Italian green roofs. For each species, there is a different approach in order to propagate them in an efficient way. It might be by seed, by cutting, or by tuft division. And the third might be the worst because of the low number of daughter plants from each mother one. One of the main targets of the test was evaluating the ability to propagate plants directly in green roof condition, as already established in sedum species and other succulents. Such method would overcome transplant stress, incompatibility between nursery and green roof substrates, and would be an easy way to fill bare patches during the maintenance. The action started from a selection of more than 40 green roof species in a green roof simulator, which is represented in the pictures on the right. Cutting trials referred to 15 species, seed germination to 6 species, and a division to 3 species. The different species tested belong to many genus. They should naturally have features of resistance to the hostile environment we find in a green roof. Rain, hail, water stress, excessive wetting, wind, thermal excursion, high solar radiation, and so on. It's worth observing what occurs in nature and selecting plants according to their natural habitats, similar to the green roofs ones. Many species were native of Italy, which means they originate from Italy or sometimes from Lombardy, the specific region where Como is. These plants represent the natural important biodiversity often compromised by invasive exotic plants. In particular, it's worth evaluating species not according to taxonomic classification, but morphofunctional and ecological characteristics, like the interesting classification based on biological forms by the Danish botanist Raunkier, according to which plants are considered by their morphology and the way they overcome the adverse season. Most plants adapted for green roof conditions belong to the two biological forms of hemicryptophytes and chamephytes. The formers are perennial plants whose buds are at the ground level, and so during the winter they are protected by snow and fallen or attached leaves. They are the predominant biological form in Europe. The latters are little shrubs whose buds are 30-50 centimeters height. They are everywhere, but especially in arid environments, both Mediterranean and sub-desert ones, both mountain, alpine, and Arctic ones. They generally resist to summer drought, to low winter temperatures, and grow in mineral, stony, and gravelly ground, or even on the bare rock. Another interesting approach is the use of Ellenberg indicators, which describe growing requirements of species concerning climatic variables like temperature and edaphic conditions continentality, moisture, pH, nitrogen, and salinity. In particular, specific range of values of indicators ecologically circumscribe a set of species that should not require repetitive irrigation or other constant maintenance interventions in an ecosystem similar to the Green Roof 1. We used species whose values of Ellenberg indicators were almost similar to those written on the right. They live in full light conditions, in hot and dry places, in low fertile soils. In this table, there are Italian species cultivated in the Green Roof simulator and their Ellenberg indicators. In this table, I reported only the species of the Italian green roof built during the project. We observe they belong to the two biological forms of hemicryptophytes and camephytes, and their habitat of origin is often arid, sunny, and stony. Other parameters to consider might be physiological ones like water need and water stress resistance, type of photosynthesis, C3, C4, and CAM plants, chlorophylls and carotenoids content. During the project, we tested the resistance to water stress in many green roof species, and in particular, we evaluated growth index, chlorophylls and carotenoids content, the ratio carotenoids chlorophylls, proline content, and relative water content, an analysis which describes the water status of the plant during the time. For each species, plants were irrigated with the gravimetric method according to 3 different values of pF. pF is a numeric index correlated to the water potential, which quantifies the work plants have to spend for root absorption. pF is the co-logarithm of absolute value of water potential, and its advantage is the simplicity of its scale, because it may vary from 0 to 7, and it has a linear scale and not a logarithmic one like water potential. pF1 is the water-based condition for the reference species, sunflower, while at pF 4.2, the species reaches the wilting point and dies. Many green roof species are able to live at higher values than 4.2. In the trials, we test values of 4.5 and 5.3 with high differences in water content. In this table and in the following 2, all results of water stress trials are represented. Many plants showed similar results. For example, Armeria marittima reduced RWC and evapotranspiration from pF1 to 4.5 to 5.3, but it was able to grow through the whole trial, even in high water stress, although with less rate at high pF values. The carotenoids and total chlorophylls content increased from the beginning to the end of the trial for all species, not as expected, but there are different studies which report this fact, probably depending on the particular species. After the first ecological and physiological approach, we did some trials to test direct propagation on the species on the green roof, in green roof conditions. The former trial I'm going to explain is a seed trial in which we tested the germination of 50 seeds per lot of 6 species in 2 seasons, autumn and spring, and in 2 environments, outside and inside. A complete randomized block design was imposed to autumn and springtime trials with 4 replications. For all the species, a green roof substrate called Malta 1 set up by MAC SRL at the beginning of the LifeMed green roof project was used. It's worth pointing out that green roof substrates are not suitable for seed germination because of the raw particles they are made of, a feature useful to avoid weeds but which can also decrease the plant propagation of cultivated species. In the diagram on the left, the monthly average minimum and maximum temperatures recorded in the greenhouse environment are indicated, where relative humidity was always above 95% and temperature was rather stationary. In the diagram on the right, we observe the weather external conditions of the 2 periods of trials. In particular, we observe that winter was rather mild, with the temperatures never below -5 degrees centigrade. This slide represents the autumnal germination of different species in 2 environments, blue for indoor and orange for outdoor. We observed that outdoor germination was better than the inner one for Dianthus, Ruta, and Origanum, while the inner one was the best for Teucrium, Plantago, and Allium. Allium didn't germinate outdoors, and outdoor poor germination occurred also in Plantago, whose germination increased from 10 to 50% in March. This species has a complex type of dormancy in some seeds. Repeated cycles of drought and wet conditions seem to break dormancy. Outdoor autumn seeded plantlets incurred in survival problems in winter. This slide represents the springtime germination. In spring, the percentage germination of plants grown indoors reached the potential for each species. On the other hand, in the green roof simulator, germination reached only 5%, with Dianthus cartusianorum achieving 25%. Allium germination outdoors was unsuccessful even in spring. Another factor which is crucial in plant establishment is the mortality or the survival rate of seedlings. The mortality that spring sound species in the simulator encountered after about 100 days from germination is a key factor to consider. In the autumn, seedlings' death is caused by winter low temperatures. In springtime, it's caused by the drought coming in summer. Therefore, not all the species tested can spread naturally on the green roof. Experience shows that Potentilla neumaniana can spread all around the green roof by seeds. This is also relevant to Thymus species, even if at an inferior rate. In the cutting trial, rooting was investigated, combining season and species employing the green roof substrate called Malta 1. In the picture on the right, weather conditions of the trial period are represented the same of the seed trial. 15 species were used, treating or not their cuttings according to the best practice reported in the technical literature. When treated, the cuttings were immersed from 5 to 10 seconds, with the exception of flomis, which required 5 minutes, in a solution of the rooting plant growth regulator, indole butyric acid, at a concentration according to the species. The experimental unit was of 10 cuttings, and a split plot design with 4 replications was adopted. Cuttings were put in the open-air environment, the green roof simulator, and rooting was evaluated 90 days later. Sedum album and sedum acrum achieved 100% rooting as expected in both the seasons. Only Santolina gave 100 rooting in autumn and about 80% in spring. Rooting of Cerastium, Thymus, Lavandula, and Teucrium was poor or none at all in spring, while the autumnal rooting had almost always the best value. In the case of Mesebryanthemum, rooting failed in both seasons. This may have been related to low temperature, considering the requirements of the species. In spring or summer, rooting may prove more successful. This requires further testing. Root length was longer in spring than in autumn in Cerastium and Santolina, despite the lower percentage of rooting. The roots of all the other species elongated better in autumn. Except for Santolina, root number was higher in autumn in all the species tested. And without counting species which didn't root in spring, most plants reached a taller height in spring than autumn, when generally showed a more compact habitus. Only lavender and Thymus vulgaris were shorter in spring than autumn. In conclusion, it's worth selecting species according to different approaches, such as ecological and physiological aspects, and not only taxonomic ones. Direct propagation depends on different factors: species, climatic conditions, seasons, and substrate. And I conclude my report with a picture of our beautiful Italian green roof. Thank you for your attention. And now I introduce my colleague Alberto Tosca, who will speak about thermal flux.
First of all, a few words about the issues, environmental issues of Italian climate. We see in this data from Brunetti that temperatures rose since 1860, when started the Industrial Revolution, and in 1960 we had a major increase in temperatures of about 2 degrees. 2 degrees in respect of the reference temperature of 1960. This is one problem of our environment, and in the city the problem of temperatures is much higher also. Another problem is the different anomalies we can find in temperatures in Italy. Worse anomalies happen in the north, where we have more than 2 degrees anomalies in respect to the 1 degrees for the south of Italy. Now, just a few words about a balance of energy that is incoming on a roof. Convection, emitter radiation, reflection are the cause of the exchange of heat flux. In the case of the green roof, we have some term that change the value in the balance. We have some different convection, but overall we have evapotranspiration that take away that change the thermal balance of latent heat. We have some more mass, thermal storage of the substrate in respect of the thermal mass of the entire roof, but it is dependent also on water content. Then we have also, but is negligible, the thermal storage of the vegetation, and is negligible also the metabolic accumulation, because it's about 1-2% of the whole balance. Our sites where we make our monitoring are both in Minoprio and in Milan. Minoprio is has a latitude of 45 degrees and is located at 300 meter. I'm sorry. 300 meter on sea level. Milano is only 100 meter on sea level. Minoprio is green roof is here. Next, in the north, we have the park of the Fondazione Minoprio. In the south, we have a greenhouse of the Fondazione Minoprio. Here is the building where professional trainings occurs. We have pupils that work all around. Here is the situation of Politecnico of Milan, where we have an historical experience on green roof, started many years ago, and there are many plots of different kind of vegetation. In this plot, we renovate vegetation, but also substrate, growing media, as we have in Minoprio. The drainage system is equal to us in Minoprio. Milan is about in the average is about 1-2 degrees more than Minoprio, and here is the layout of our green roof. You have already seen by thanks to the presentation of Massimo. Pardon. Here is the monitored environment, where there is a green roof with some species like Armeria, Dianthus grazianopolitanus, Dianthus cartesianorum, Potentilla neumoniana, Thymus serpyllum, and spread all around the plant we have sedum album that make some kind of mulch to help plant in their growth. On the other side, we have the reference roof covered with about 4 centimeters of gravel. The roof in Minoprio is made of a false ceiling, where we have a thermocouple. Then we have the corrugated sheet metal, where we put a thermocouple and a heat flux sensor. Here we have a lightened concrete, and then the insulation with the polystyrene. This is in fact a reverse roof where insulation is outside. Then we have after a protective geotextile, we have the drainage system and the MACSET substrate. Here on the waterproof membrane, we have a thermocouple and temperature and a water sensor also in the middle of the medium. Our roof have a U value according to the national rules, that recent rules, of only 0.24. In Milan, you have already seen the position of the plot. Is a 30 square meter area. Has been planted with our species in the same arrangement. This is how the green roof at Politecnico is done. Please consider that this building is much older than ours. It is about maybe more than 30 years. And this is the building 15 of the Politecnico. You can see you can see the slab and the sensor. You can see the heat flux sensor, the temperature sensor at various level. Here is an example how we do the recording of the data that have been done by means of an air software that take the records and put in a database, MySQL database, and then use to make a graph. Now we start with the data we recorded. And first of all, albedo is the reflection, the fraction of reflected incident light. And we can see the measure we achieved in May, July, August, and December. You can see that this is a bituminous membrane, that an old bituminous membrane that is on the building. It's the lower albedo. This is the data of our gravel on the roof, and then all the species we used. Please note how albedo is higher in Cerastium when it's flowering, because of the high coverage of white flowers that make these high values. But also you can see these two varieties of Dianthus grazianopolitanus. The pink, light pink flowers make higher albedo data. In the summer, many species lower are without flowers, and here you can see Cerastium that in the middle of the summer have a lower values because of leaves that the basal leaves that desiccated, and while in the winter his values are higher because of his light green and airy leaves. Now we can change to see the data on the waterproof membrane. That is a reference parameter for green roof. You can see the situation in July 2016 where the temperatures in blue overcome 30 degrees, and you can see that when the temperatures reach the 35, the air temperature reaches 35, the membrane temperatures of the gravel roof, the reference roof, reach about 60 degree or 60, see, in this day. Why we have a higher loss during the night. The excursion of these, the range of these temperatures is more than 40 degrees, while in light green you can see the range of temperatures of the green roof. They are more stable, only about 4 or 5 degrees in the day. Looking at an example of a day, we can see that the peak of the temperatures come on the reference roof, come in just in the midday, while the peak of temperature of the membrane under the green roof is at 5 p.m. The lower temperatures happen in the morning at about 6, 7 in the morning for green roof, while some hour before at 3, 4 a.m. For the gravel roof. In the winter, the range of temperature is less than in summer. You can see here some range in the gravel, in the reference roof, of about 20 degrees, while is almost constant in under green roof. Here an example of the in a day, in a winter day, where the maximum temperature is about 2 p.m. and while for the gravel roof is in the evening. Now, what about at flux? At flux, I am showing you the calculated flux, not that of the sensor I showed before, because the position, we have some problem with the position of that sensor that give not us good data, because maybe of the service that are in the false ceiling of our room. So we choose to calculate between two thermocouple, one from the membrane and the other of the ceiling, the values. This is an example in the summer. You can see the high range of at flux in the gravel roof, in the reference roof. Please take into account the gain of energy, the gain of weight during the day, and the loss during the night. Of course, under the green roof, these trends are more smoother, with a top of 8 flux coming in at 8 in the night, 8 p.m., while the top in the reference roof is about at about 2-3 p.m. This is the situation in a winter day, where the trend in green roof is almost flat, and we have a loss of about 4 watt per square meter, while in the reference roof we have about 8 degree loss, 8 watt per square meter, watt per square meter loss in the night, and about 3-4 in the first afternoon, early in the afternoon. Then from all these 8 flux, we try to calculate energy loss or gain by our green roof. And you can see that green roof, that is the light yellow bar, is over in loss, while in the summer months the reference roof have a gain of height. Please consider this situation in the other months. In the winter months, the loss of energy is always less in green roof than in the reference, but in the springtime and also here in September, the loss of energy is higher in green roof. This situation may be linked to the activity of the plant that make more evaporation while growing and subtract heat from the roof. More or less, we have a huge difference between green roof and reference roof in the summer, in the cooling months, where we spend energy for cooling the rooms, the environment. But the values, the absolute values are are small, so the gain is not really so high. In the heating months, the value of the energy, the energy balance are much higher, but the difference in favor of the green roof is not so high in terms of percentage, is 1%. This is a situation relieved in May in Politecnico. You can see the same pattern, here the global radiation. We can see the loss of temperature of heat in the because the room inside are used. So people go in and you can see the heating going, more heating pass through the roof. Here is an empty day of the rooms. The balance in Polytechnicos is has the same, more or less the same amount as in Minoprio, as absolute values. But even in a green roof, in summer months, there is a gain of it. This gain in energy in Polytechnicum, but not in Minoprio, can be explained by the fact that technology of the roofs have changed in 30 years. So we have a very low U value, while Polytechnical buildings has a higher value of transmittance. The case, the difference behavior of a green roof in springtime has been reported of also in foreign experience, where green roof in spring times send outside more energy than a reference roof. We have at the end of the experience, we have not shown very big difference as in other experience between a reference roof and a green roof. But the benefit of green roof is also in terms of at Iceland mitigation, not only in the building balance, energy balance. What we show you are in just a year or more data collection. Many years are needed to confirm the data we show you. And thanks for your attention. Bye.
I'll be introducing another document that we have drafted, which is a policy proposal document. I will be followed by Mr. George Cutajar. There he is, from MCCAA, and he'll be speaking about the green roof standards for Malta. After that, we would have Chiara Catalano. She will be introducing biodiverse green roofs, and we'll end our session with another life project in Poland by Kinga. It's the Radom project. Okay, and then we'll hope to have some time for discussions and questions. So what I'll do, I'll try to go as quickly as possible because we are quarter of an hour late. It is widely accepted that urban areas have problems. I hope that by now we've realized that urban areas have got problems, and that these problems are affecting our quality of life. Green roofs are considered as part of green infrastructure, all right, and they have proven benefits to society in a number of ways, and we've said previously that these benefits are both for the individual, the community, and biodiversity. Okay. All right. The LifeMed Green Roof project has illustrated that green roof technology can successfully be implemented and maintained with minimal effort and water resources. We cannot say otherwise. Plants need to be watered, okay, but it is not as demanding as one might think in terms of water and even in terms of management. Okay, it all depends, however, on the type of species one uses, all right, and what one expects. We've mentioned that when green roofs are installed by individuals, they contribute to social benefits as well. We have to keep these in mind, okay? When an individual has or installs a green roof, the benefits are not just enjoyed by the individual, but they are also enjoyed by society, all right? So whoever constructs a green roof is contributing something to society. All right. However, although green roofs provide a number of social advantages, it is the private benefits which will induce owners to install green roofs. We have to be realistic here. Okay, nobody is going to spend all that money to build a green roof so that his neighbor enjoys the view. All right, the individual has to enjoy the green roof as well, obviously. So it is in the interest of a nation, all right? It is the interest of society that green roofs are replicated to policies, incentives, and regulations, okay? Green roofs benefits are only experienced if the technology is widespread over the territory. Our green roof here will not solve any problems, okay? It might have solved some issues with our administration, because now rather than looking over the black membrane, now they're looking at some plants. They've got butterflies there and birds, okay? And the benefits, that sort of benefit is realistic. We have conducted a questionnaire a year ago, and we've repeated that a few months ago, and that is the result we got, okay? So if you go on our website, there are the results of this questionnaire. There's a report there, and that came out pretty clear, okay? That people enjoy their office more because their view outside the office is pleasant. So obviously it's useless. We cannot wait for people to voluntarily construct green roofs, okay? It's not gonna happen. We know what happens with PV panels, okay? Nobody installed PV panels before the incentives were put in place, okay? 6 phases have been identified in establishing green roof policies. These phases are not rigidly classified and can be implemented as necessary and are interchangeable, okay? And I'll go through them quickly. Introductory and awareness. Stakeholders are to be made aware of green roofs and their benefits. Such awareness can be instilled through workshops, information sessions, visits to demonstration green roofs. This is one of such activity, all right? We've had, as the LifeMed Green Roof Project, we've had published articles in newspapers and other journals, organized public lectures and information sessions. We had NGOs asking us to conduct lectures, and even schools. All right, we had the Department of Education come here and visit the roof, because that is a very important education tool. So throughout these past 3 years, we had a lot of information sessions, and we tried to introduce green roofs to schools as well and other entities. In fact, one of the schools here in Gżira has actually built a small green roof for the students. Community engagement, to involve stakeholders as in the above, targeting especially design professionals, construction industry, educators, NGOs, community leaders, and policymakers. Obviously, not policymakers, the design profession, for example, has a big role to play, an important role to play, because they are the make or break, okay, of within the design sphere, within the construction industry. But obviously, we have to also target educators and community leaders and policymakers, because they are the ones to push green roofs on a national scale, all right? And that would also influence the design professions. Important to raise the profile of green roofs through meetings and workshops. And as I said, we have been doing that for the last 3 years. Action plan development and implementation. Green roofs should not be seen as a burden, but as a benefit to society. This was the case in, if I'm not mistaken, Berlin, way back in 1983 or so, when they started implementing green roofs. Okay, the construction industry at first thought it was a waste of money, it was a waste of time, but eventually the technology got ground, and nowadays it's not questioned. You know, it's just like any other policy or any other regulation which there is in the building industry. So what we did is we created the baseline data on green roof performance, so now people know what to expect. Okay, it's not it's not cast in stone, because obviously climate plays an important factor in green roof performance. But at least we know what works and what doesn't. Establishing the insulation and stormwater management potential of green roofs, locally publishing a standard document. These are important in pushing towards an action plan and the implementation of green roofs. Technical research is also very important. We've spent 3 years here, just over 3 years, in fact 3 years, 9 months, researching green roofs. We won't stop here, we cannot stop here. We have to sort of go further, because we have more questions than we have answered, in fact. Program and policy development involves the establishment of schemes to encourage green roof dissemination and at various levels. Schemes should consist of policies, incentives, and regulations to target different stakeholders. We have published this document here. We have had meetings with government and even the opposition. We have had meetings with various departments and government entities. And as I said earlier on, things were moving forward. Unfortunately, halfway through our meetings, we had the election, and things sort of stalled a bit. But we hope to catch up again, you know, with these discussions. Continuous improvement. The effectiveness of policies, incentives, and regulations should be assessed periodically for effectiveness. Okay. If we look at the standards, that could be revised every 5 years. More research will be carried on at the university. So obviously, we will need to fine-tune what we already know so far. Types of measures. So we have 4 types of measures. We can look at direct financial incentives, indirect financial incentives, ecological compensation, and incorporation into regulations. Direct financial incentives are very similar to the PV panel system that we have, where you purchase your green roofs, your PV panel, and you get a rebate, all right? Or you might get a tax cut or something of that sort. So subsidies can be determined by the area of the green roof, so many euros per square meter, or reimbursing a percentage of the cost for the construction, all right? Such subsidies could be subject to conditions such as media depth. Okay, it all depends on what one wants or what one needs from green roofs. All right, whether you want flood mitigation, whether you want to reduce air conditioning costs. Okay, so these subsidies could be subject to particular conditions. Okay, can be subjected to minimum maintenance period, obviously, because you don't want individuals to get the subsidy and then he abandons the green roof. Okay, so you can put down minimum maintenance periods, and it can even be targeted towards specific locations. The advantages and disadvantages, yeah. The voluntary adoption of green roofs through the scheme. All right, so you have people actually volunteering to construct green roofs on their property. They can be designed to reach specific performance and purposes. They can be encouraged to, they can encourage the adoption of green roofs in specific target areas. They are effective for retrofit roofs, and the area of green roofs constructed is proportionate to the benefits gained. All right. Limitations include capital sum required. Obviously, if government has to reimburse a sum of money, then obviously there has to be capital. Indirect financial incentive relates to the pay-per-use of stormwater disposal and usage. That is charges for water consumption. Okay, so the more water you consume, the more money you have to pay, and also water runoff from the properties. What does this mean? If you have a property which is totally constructed, all right, either with the building or either built or consisting of hard landscaping, so no water is practically absorbed, it all goes into the street. So you pay a sum of money because you are actually constituting a problem. All right, you're directing water that lands on your property into public domain. All right, and that is contributing to flooding. All right. On-site stormwater control reduces runoff volumes and peak flows discharge into the public realm. So if you have a well, if you have a garden, if you have a green roof, then obviously you are contributing to reducing the problem. So obviously you get less fines, to say so, all right? You're less taxing. Indirect financial incentive advantages include stormwater fees, encourage protection of water resources. They are an effective way of encouraging green roofs and green infrastructure. Why? Because if I've got a property which is totally built, if I put a green roof on top, then I get a reduction in the fines I have to pay or in the taxes I have to pay. Encourage the voluntary installation of green roofs. Such policies can run indefinitely because obviously the government or the policymaker wouldn't have the need of capital, all right? Easily communicated to the public, it works well with both new and existing buildings and are independent of other means of funding. Limitations, cost of administration, a system of inspection and maintenance may be needed, and opposition to fees by the public. Obviously, if you're going to tell people, listen, they have to pay, they will oppose it, but after all, that is what you want because you want green roofs and other green infrastructure to be implemented. Ecological compensation. This looks at greenfield and brownfield sites which contribute towards mitigation of flooding and biodiversity. If you've got an unbuilt plot, all right, any water runoff which ends or it finds its way into that plot is absorbed. And so you are contributing to mitigating flooding there. All right, their construction reduced public benefits. Obviously, green roofs compensate for such losses and benefits. If you had to build a green roof over a plot which has been newly built, then you get compensation for that. Ecological compensation measure benefits include green roofs could provide ecosystem benefits which would have otherwise been provided by the greenfield sites. This measure could be used in addition to other measures and can target specific locations. This measure could target those developments which have the greatest negative impact on ecosystem services. Limitations, cost of administration, and the system of inspection and maintenance may be needed to verify, obviously, what's on site. And incorporation into regulations, the adoption of green roof technology should be based on two actions, incentives and regulations. Incentives adopted voluntarily, but regulations are imposed. Okay? There are cases, for example, in France, where it is imposed that any industrial or commercial building should have either green roofs or PV panels on the roof. Okay? That's a regulation. But then you could have an incentive, as we were discussing earlier, that if you have a green roof on your property, then you get a tax rebate or something of that sort. Advantages: a reduction in the expense of financial grants, a more effective and efficient target for new developments, a major boost to investment in green skills and jobs. The challenges: protests by owners, obviously, and developers due to extra cost. Regulations could be difficult to implement on existing and retrofitted projects. Okay? Green roof policies worldwide. As I said earlier on, green roofs started in Germany way back in the 80s. Okay, then Austria followed, and a number of other European cities and countries. Eventually, it crossed the Atlantic and it went to America and Canada. Why? Because green roofs offer a lot of benefits. Okay, if we had to look at some statistics, Germany has the highest area, at least in 2004. Germany had the highest area of green roofs with an estimated 68 million square meters of obviously roofs, and with an estimated growth of 8 million meters squared per annum. Okay? Figures in other countries might not be as high, but they are expected to increase substantially. And there we have the areas of green roofs in other countries, and that's it. And I can say it because there's a Polish person here. I've been on the largest, on the green roof in Europe, which is the University of Warsaw, which is spectacular as well. It was January, so it was all snowy, but it was impressive as well. Local policies supporting green roofs. I won't be going into them that much because of time. Green roofs are not specifically mentioned except in one document, okay, which is the National Environment Policy. Other policies do somehow encourage the concept of green roofs, but the green roofs are not mentioned specifically, okay? Obviously, if the construction industry are not aware of green roofs, if people are not able to appreciate the benefits of green roofs, and if policymakers and institutions do not push towards green roofs, then it's useless having these policies there. So that is why we are proposing that other means of incentivizing or other means of regulating the green roofs would be put in place. So we looked at possible green roof policies for Malta. We looked at direct financial incentives, indirect financial incentives, regulations and policies, and examples as in demonstration green roofs. Direct financial incentives relate to subsidies, grants, and low interest loans to install green roofs which meet specific criteria. As I said, I don't want to repeat myself. This is very similar to the PV panel system that we have, okay, whereby you get either a tax VAT refund or a discount or some sort of direct financial incentive which would benefit or which would encourage green roofs in the local context. Indirect financial incentives, I think personally, to be honest, I think this is the fairest of all incentives. Why? Because much of the problems we have today, if we're looking at flooding, for example, it's happening because of soil sealing, okay, and the lack of water harvesting facilities. All right, we know that there are a lot of buildings being constructed without wells. All right, so people are getting richer. All right, they're getting financial gain, but at the same time they are loading the public with problems. All right, so I think putting a fee on soil sealing is a very fair system, whereby if you have a green roof, if you have permeable surfaces, according to the coefficient of your system, all right, you get a discount. And I think that is pretty fair. Obviously, with policy makers, it doesn't sound right because people won't agree to it. But then again, if I ask who wants to pay taxes, nobody would want to, okay, but we still do. Building regulations and policies. Green roofs are not specifically mentioned in building regulations, as I said, and policies, and this is reflected by the fact that green roofs are not installed, okay? Unless they are specifically referred to and encouraged, there is little incentive for developers to incorporate them in their proposed schemes. Design professionals need to be aware of green roof benefits, okay? Issues such as overlooking into third party, there are issues, light pollution and possible public nuisance need to be addressed as well. It's not all, how would you say, hairy-fairy, okay? There might be cases where people start using their roofs for other activities as well, apart from the green roof, and obviously one has to take it. It's something which somebody mentioned, and to a certain extent, it could happen, okay? So one has to keep these things in mind, not to obviously create any problems. Such incentives could target both businesses and residential buildings as well. In terms of businesses and corporate buildings, there are papers, there have been studies showing that green roofs on, or rather offices overlooking green roofs or with green roofs on the premises make the employees work more efficiently, or people prefer or enjoy more the experience of being at work. So there's also the psychological aspect of it. Demonstration and leading by example. Leading by example is a means of gaining trust and demonstrating shared responsibility. Both central government and local governments could lead by example and commit themselves to a green credential, right? In fact, we've in our discussions with government, we did see a bit of a will, okay, that certain buildings could be greened, even in local councils, for example, okay? And finally, but not least, awareness. A scheme, however beneficial, will not be upheld unless there is proper awareness. Awareness is one of the LifeMed Green Roof project's aim. However, this must be extended well beyond the project's completion. We did as much as we could. We had the demonstration green roof. We had articles. We had radio interviews. Okay, but it must not stop here with the project. We have to keep on going. We have to keep on pushing forward. But it's useless for the university to push green roofs, and that push is not, how would you say it? It doesn't make sense if policymakers and NGOs, for example, do not push as well for such incentives to be put in place. To reduce the possibility of failed green roofs, it is important that any incentives offered are linked to green roof construction standards. One thing we don't want to see is green roofs popping up everywhere, okay, with no regard to safety, with no regard to the technical issues, okay, because then green roofs will have a negative implication, and that would mean the end of the technology. All right, to conclude, green roofs should not be a means of further expanding the urban boundaries or increasing building density. All right. What worries me is that we would start having the situation where we say, yes, you put a green roof, you can build here and there. Okay, this is not the aim. All right, the aim of green roof is to mitigate the problems brought about by urban areas. Green roofs are a means of mitigating issues experienced in towns and cities which impact on quality of life of urban dwellers. This document provides a review of options to increase the number of green roofs on a national scale. The larger the surface area, the greater the benefits. Government and agencies would do well to work together to help in the implementation of green roofs over a wide territory to combat climate change and meet energy targets. And I think that was the last slide. Yes, thank you.
So, good afternoon, everyone. I am George Cutajar. I'm coming from the Malta Competition and Consumer Affairs Authority. Back in 2013, LifeMed project approached MCCAA since we, as an entity, we have the legal obligation to develop national standards. Back then, in 2013, they approached us and we agreed that we go for a national standard on the construction of green roofs. As in 2016, I think at the middle of the project, we started the project for developing a national standard. The process mainly consists of setting up a technical committee made up of national experts. We invited these interested parties and to develop the standard. In fact, the standard is published, and the standard also contains reference to all those participants that developed the standard. So, a brief description of the whole process, how we developed the standard. Basically, the national standard was developed in 9 months. We had a series of meetings, and after we had the final draft, the standard was put for public consultation. During this period, a period of 2 months, we invited feedback from interested parties outside the technical committee to give us feedback on the actual standard. During this time, we actually received one type of feedback regarding the life cycle perspective about the material that is actually used in the green roof itself. In I think June, we published the standard. As an authority, we have the remit to publish the standard in the Government Gazette. Just one note regarding the standard. It's a standard. When we publish a standard, it's on a voluntary basis. It is not a regulation. So again, this is we developed a tool to support policymakers. In this case. So we were talking about funds. So for example, we can have a regulator that can legislate and make reference to this document, which I'm going to describe in a few minutes. We can have also tenders that can specify that can make reference to the standard, etc. So even schemes, funding schemes. In these few minutes, I will be giving you an outline of the standard itself. The standard is made up of 10 clauses. It's a 70-page document. First of all, it has the scope. The standard is intended to set out the basic principles and requirements for the planning, constructing, and maintaining of green roofs within the Maltese context. It is intended to be used by professionals and tradespeople working in the field. As a standard, we used a number of other references and other literature, which can be found in the normative references section. So basically, we start with clause 4. Clause 4 outlines the benefits of the standard, and I think this morning, and even Antoine hinted at some of these benefits. When we were developing this standard, we kept these benefits in mind. Mainly, a green roof for insulation purposes. A green roof that can give value to a property, increasing the aesthetic value of urban environment. increasing the lifespan of buildings and reducing maintenance cost. And the fourth benefit was regarding mitigating flooding, supporting stormwater management systems. Then we started by defining 3 types of green roofs. Mainly there are extensive green roofs, simple intensive, and intensive green roofs. The main characteristics distinguishing between the various green roofs are the substrate, the type of plants of vegetation, the irrigation system that is going to be used. One needs also to consider the maintenance one needs to keep on the green roof, and also the accessibility to a green roof. So that was clause 5. Then clause 6, one of the structure of the standard, we adopted a process approach, which means before constructing we need to plan. And before planning, we need to have objectives. So clause 6, it's about planning. It outlines what are the agents of a green roof, what the structural requirements. Before building a green roof, you need to check out whether your structure actually can hold that green roof. Site analysis that can be done by, for example, architects and professionals. What type of access you would have for green roofs, any roof faults and the roof designs. Water tightness, this is very important because before start actually constructing the green roof, you need to check out what is the water tightness of the roof itself. Design loads, the draining irrigation, compatibility of materials that are going to be used, and also the end of life. What happens if that green roof has to be demolished? So we also considered the materials that are going to be used in a green roof. Clause 7, we started by giving the methodology that is going to be used for the construction, the materials and components for a green roof. So we started with the roof slab, with the proof layer. Then the second rail would be a root-resistant barrier, protection layer. Then we have the drainage layer, filter fabric, vegetation support, and the vegetation itself. So this is a schematic diagram of how a typical green roof would look like, the cross-sectional diagram. Other considerations. This clause provides other considerations which contribute to the intended benefits to ensure that we actually maximize the benefits of green roofs when it comes to water retention, protection against sintering, drainage systems, the joints protection against emissions, for example, wind loads, fire characteristics, edging, paved surfaces, and the furnishing of the actual green roofs. After constructing, one needs sort of to commission the green roof and also do final inspections. This clause defines 3 minimum confirmation tests to guarantee that the construction and the agronomic interventions carried out meet the design requirements and the output requirements. For example, confirmation of water tightness of the waterproofing system on completion of the dam-proof membrane, confirmation of the plant and other services, including those related to plumbing, electrical, and air conditioning, and confirmation of the green roof does not impede the proper function of apertures and emergency exits. So these are 3 key tests related to ensure validating sort of the green roof. We also considered maintenance, requirements for a maintenance plan, issuing of a user manual. When one comes to commissioning, one can deliver a user manual, a maintenance manual, and also a maintenance program. The level of documentation depends on the importance and intervention specificity. Initial maintenance to achieve the projected greening, long-term maintenance, other unscheduled maintenances, etc. And at the end, periodic inspections and repairs. Of course, it all depends on the type of green roof that one is considering. So that was the last clause of the standard. The standard is currently available from MCCAA. I am sure that, for example, architects and other companies in this field would like to review this standard. I am giving you the contact to whom you may we can make available the standard, also even for regulators, for example. Thank you.
So the topic, as already Antoine said, first of all, thank you for the invitation. And I apologize for Stefan Brenneisen, who is my boss, actually. He should also be here, but he couldn't make it. And so I'm glad that I visit now, finally, Malta, even though I'm a neighbor, since I come from Catania. I never visited Malta, so that's my first time, and I'm very happy to be here. So the topic of today, of my presentation, is biodiverse green roofs. As a matter of fact, I did also a PhD on that topic, and I developed also some Mediterranean features that I will explain at the end. So I will go then into some examples in both temperate, which is actually a Swiss, German experience, and then Mediterranean situation. Maybe can I have the microphone, because I feel like I cannot move. But yeah, whatever. So first of all, as already have been mentioned by many today, actually I have the impression it has been a very long conference, but as a matter of fact, it's only one day. Very intense indeed. So why we have to conserve nature in city? That's very, and the first thing from where to start. Thank you. Grazie. So that's the first thing from where to start. I always try to make myself clear why I'm struggling in this field, because the more I go around, the more I see is not always, green roofs are not always welcome, and green infrastructure in general are not always welcome, especially at our latitude, so Mediterranean climate. So why we have to preserve nature in city? First of all, because we are too many. We will reach 10 billion people in 2050, where in Europe at the same time we will be more than 80% living in cities, which is actually causing the well-known phenomenon of urban sprawl. The two pictures shows the two great examples in the world, basically. One is a Tokyo settlement, so megalopolis, and with more than 38,000 million, would be nice thousand, but it's million people. And London with 10,000, again, million, million people. Of course, that's like a very simple example of how the city is actually eating in the surrounding. That's why we talk about city metabolism in general. And this is just a scheme done by a Finnish architect, Elias Saarinen, in 1943. And he was just sketching the development of London from 1840 to 1929. And nowadays, of course, the situation is even more extreme. As I mentioned before, we talk about urban metabolism. And we also consider cities, I mean, the ecologists consider cities as well as heterotrophic ecosystems. What does it mean? It means that actually cities consume energy from side sources, and they transform them to run transportation of people and goods and to develop technology and industry and products in general. So what is actually happening in cities is then affecting the environment, in the sense of heat and waste in general, just to be easy. But of course then the result is very clear and then evident. And in the sense of the alteration of biogeochemical cycles, the alteration of local climate. As for biogeographical cycles, of course I mean like water, for instance, because we spoke a lot about water cycles, which have been completely altered by just soil sealing the environment. And then local climate, so the urban Italian effect, and of course pollution, so the fine particle and etc. Then as regards the land use and cover, then we know we are all aware of just soil sealing continually. And finally, which is then the connection to green roof for biodiversity, is of course causing habitat fragmentation. But what's then the problem? Where is the conflict between nature and habitat fragmentation, then development of cities? The problem is that cities are not just randomly spread around the planet. Actually, the density of population is just concentrated in its biodiversity hotspot, and one of the hotspots is just the Mediterranean basin, so where we are. So that's why we have to absolutely concentrate in urban environments, because we are always more environments. So I mean urbanities. So urbanity is becoming always more popular and constant, and that's why is the place where to intervene. But there is a but. Fortunately, there are like designers, and they see the glass not half empty, instead half full. And I cite, and I quote here, Gilles Clément, which is a French landscape architect. And I really like this concept of the third landscape, because it's actually describing quite well and very well the situation between the remnant, the habitat remnant inside the urban cores, as is shown there in the. So that's kind of a scheme of a city, of a settlement. So you have like scattered habitat fragments, which are denser and smaller in the cores, and then you have bigger but more distant areas in the peripheries. And of course, the biodiversity of the third landscape then is influenced by the pressure of the anthropic territory. Then we go, of course, into green infrastructure, because, by the way, this third landscape is indeed the green infrastructures, and then in particular the urban green infrastructure. And the backbone of the green infrastructure in Europe, as everyone knows, is the Natura 2000 network, which was defined by the Habitat Directive and the Bird Directive in 2009 and 1992. And of course, what is important for the survival of this network is, of course, the connection between them via stepping stones and corridors, ecological corridors. And then comes, of course, why we are talking about green infrastructure, urban green infrastructure, so where we can act in cities and how. Of course, with the creation of water roof, but also vertical roof, and of course green roofs, together with forest belts, which give millions and plenty of benefits, which we already are aware of after the seminar of today. So I'm not spending any words. So finally, green roof, of course, are part of the urban green infrastructure. And to quote, I like this definition because it's very simple and easy. So green roofs can be synthetically defined as surfaces covered with growing medium, intentionally vegetated and or spontaneously colonized. I like to underline or highlight this spontaneously colonized, because actually the green roofs started just with spontaneous colonization in the old German roofs of the 19th century. So it's something we have to keep in mind, that green roofs are not like static ecosystem, but they are dynamic. So we don't have to just try to make them like in a picture. It's not a review, like a journal, it's life. So before you spoke about the typology of green roofs. As a matter of fact, there are three main typologies. So the intensive green roofs, the simple intensive green roofs. By the way, this is in Austria, as you know, in Germany, and that's the Waldspirale, which means actually a spiral forest with a very direct connection with the vertical forest in Milano by Stefano Boeri. But this was dated back 1990. And those are some green roofs which I investigated in 2015. I made a study on these roofs, which are, of course, these are only two roofs that are like a settlement. And that's the Waldorfschule. Do you know the Waldorfschule, how this works? It's kind of a Steiner, you know, okay. Alternative methods of teaching to kids. And they have, of course, green roofs. And they don't touch them, they don't maintain them. And we made like a 30-year survey on those roofs, just to also bring some proof that it's possible to have green roofs with not such a high maintenance cost as well. And of course, extensive green roofs. This is a roof in San Francisco, which I visited in 2013 as well, done by Renzo Piano in collaboration with Renzo Piano. Everyone knows Renzo Piano as a famous architect, and Rana Creek, which is actually a biological consultants firma. And they used only native species of California, so Mediterranean climate. And then finally, biodiverse green roof. For me, this is a fourth typology, and not only for me actually, because the British, so the UK code, the Grow code is now using them as well as a typology. What is characterizing the biodiverse green roofs? So what are the key design principles of biodiverse green roofs? So first of all, the different thickness and substrate kind. Why? Because of course in this way it's very easy to have different biocenosis. So the first thing to adjust is the substrate. So the first rule is not just to have a constant thickness, but just to vary it and provide different habitat possibility for wild flora and fauna. Together with that, there have been also used some structural designing features in the sense, and in particular, some trees and bushes. They're not bushes, they are dead plants actually. So some woods and trunks, normally piled, or just if there are branches, just put them around, just to provide shelters for insects, and also to provide some local condition for specific plants, and also temporary ponds, because we used to consider green roof just let's say sedum or mosses or camephyte, as we spoke before, so kind of woody species dominated areas. But as a matter of fact, if we vary and adjust the materials with which we are doing the green roofs, we can have a variety and very impressive biodiversity, as a matter of fact. And this is Drosa rotundifolia, for instance. This is colonizing species habitat, very wet habitat, which one wouldn't expect to find on a roof, but actually it's possible, just using the right materials. In this way, in this case, was rock wool as a water storage system, basically. Some of the biodiverse green roof turned to be biodiverse in the time. So most of them are also kind of surprise. That's why I think it's important to keep in mind this word spontaneous, not try to control every single development of the roof. And also accept, by the way, the development. And something interesting that some birds, some ground nesting birds, like the lapwing, Vanellus vanellus, is starting to nest on green roofs because of lack of spaces. There are no habitat, like normal natural habitat. So the birds are starting to nidificare, to make some nest on this kind of roofs. The problem is that the chicks need, of course, food and water, and normally these kind of substrate, shallow green roofs, so the sedum-dominated roof, they do not have enough food and water reservoir. That's the reason why this is like a trunk, which is put all around the perimeter to prevent the chicks to fall down from the roof. And also there are like temporary ponds where they can find water during their life cycle. Another important concept for me is the acceptance of the seasonality. So the color, the yellow, which for me is beautiful as the green. And as a matter of fact, this roof is built in Ottawa. Is the War Museum green roof, and reminds me as soon as I saw it. The wheat field with cypresses by Vincent van Gogh, which, by the way, is our cultural landscape, which we all know. Then some examples of biodiverse green roof in temperate climate. And first, before the, I think this slide is quite relevant about policies and regulation. The Basel case study. So Basel is a very special city, because now in terms of green roofs, but also in terms of people, because it's like a city between Switzerland, France, and Germany. So it's a very special city anyway. So this number is the number of green roofs areas in the city of Basel. 100 hectares. And what is important is this kind of exponential growth of green roofs. Why that happened, how that happened. That's because of two incentives campaign in 1996 and 97, so only 1 year incentive, and 2005, the second incentive campaign. So this number is also clear. We spoke before about the amount of green roofs built per year, and nowadays is 60,000 square meters per year, which is quite a number, quite a result. In this case, the incentives were direct incentives, so people were getting money like 20 Swiss francs per square meter if they were building a new green roof or retrofitting, which is, I think, a very important aspect also in Malta, for instance. I saw so many flat roofs, actually only flat roof. So the retrofitting option is quite relevant. Going back to some examples. This is a roof of 30,000 square meters in Basel. Stucchi, that's a Rhine. The roof was actually built with the idea to replicate or mimic the river habitats, and that's why there are different kind of substrate used, but they're not just commercial substrate. They are sandy gravel and loamy soils, together with pebbles and trunks as well. So all the principles I mentioned before are applied on these roofs. And of course, the results is interesting because you have different kind of vegetation. Go back. Yeah, from crassulaceae species, which are of course pioneer species. I think this is Sedumacre or something similar because it's yellow flowering. And then you have like this kind of stripes with bigger pebbles, which host a different biocenosis as well. So in this case, dominated by grasses, but then you have different patchiness. So what is very important by reverse green roofs is actually the spatial heterogeneity. And of course, insects are having fun on this kind of huge roofs. And by the way, there are 7 species of grasshopper living there, and also flagship species or rare species, including in the red list as well. This is another roof close by the Stucchi. This is a bit smaller, so 1,000 square meter. And I didn't say something important about this roof. This roof was built with less than 20 Swiss francs per square meter. So before the incentive, the cost more or less of green roofs was very high, ranging about 90 Swiss francs per square meter. And after the incentive campaigns, it decreased dramatically up to 20, 30 Swiss franc per square meter. So this is something interesting also for perspective and in the future application. So going back to this example, the BVB Wiesenteppich, this means meadow carpet. And this was built in 2010, as I said, at 8,000 square meters. What is interesting here is that the structure is made by plywood. So the fleck board. So it's kind of OSB. Like I think the architects can understand me. I understood you are from that field. Anyway, OSB and the structure and the load is not so high, so they cannot support so much load. The maximum is 1,000. Yeah, I mixed 100,000 and millions. I see. So it's 100. It's just 120 kilogram per square meter. What is interesting here is that the architects were collaborating with the biologists as well, and they created these waves and flat parts. By doing so, you have like hills and valleys. And of course, the water is going to the valleys, and so creating different habitat possibilities for species again, which is actually what is important on green roofs. We create habitats over there. It's not just a matter, of course, it is a matter of energy saving, of water cycle and so on, but we create also habitats. And they're just in front Alyssum species and the Vulpia species as grass and some Trifolium campestre and fantastic Echinus vulgare still flowering. So again, what is important is to accept the cycle. I mean, the roof is not dead, it's alive, just staying quiet for a while. This is another roof, Jakob Burkhardt house. This is about 6,000 square meter and built in 2001. Again, on this roof, which is along the railway station in Basel, actually between the French and the Swiss rails, And again, here the same principle applied, but with the difference that here we have like also commercial substrate, which is mineral-based substrate, and the biodiversity features are then overlaying. In the sense, in this case, we have like sandy gravel stripes, or just sand areas where also bees can nest, so the ground nesting bees, and so on. And finally, as example, finally for the first part of the presentation, don't be afraid, it's not so long, it's just pictures, because I want to create some inspiration, which I hope is working. So this is the Moss water filtration plant, or Sevasaberg Moss in Zurich. This was built, this is not a mistake, this was built in 1914, so it's more than 100 years old, green roof. And this is kind of biodiversity conservation. It's not a kind, it's a biodiversity conservation area. So when Landolt, Elias Landolt, which is one of the famous botanists in Switzerland, went to visit this roof, made like a species list of 170 different species and 9 species of orchids. And among them, Orchis morio, which is nowadays basically disappeared in Zurich, but over there are 30,000, and it's not, again, a mistake, 30,000 individuals of Orchis morio, and together with Dactyloryza and the Listera ovada. Now going a bit into the stratigraphy. Those roofs, of course, couldn't follow any rules, any norms, because it was built 100 years ago. And the roof was done just directly on the waterproof membrane, and then over the waterproof membrane we have 5 centimeters of gravel. So nowadays is everything mixed, of course, because of succession, but normally it was built in that way. So more or less 1 centimeter of gravel, and then directly topsoil. And that's the benefit of using topsoil, because in this case, you have a very beneficial species pool already for free included in the substrate. But of course, this is not true for all kinds of substrates, so one should before pay attention to it. Then, after all these examples, what happened also in Switzerland in 2013, they made as well a regulation. And this was the first one to consider the nature conservation aspect as well, included in the regulation. And they distinguish like 3 kind of green roofs, so from basic, advanced, and special. And it's clear that the advanced are the ones that use this biodiverse principle I already explained before, so I'm not going into details. But what I think is important to mention is how to collect the species and from where the species come from. Of course, they have to be Swiss ecotype, which means from the region, and can be of 2 kinds. They can be from the biogeographic region, as I mentioned, but also with any regional specification. But of course, this makes difference in classes. The best possibility is to collect the seed locally or transfer them with hay. Someone mentioned today why don't we mulch? It's actually known as a mulch technique. So actually the hay is directly taken from donor meadow and brought on the roofs. So in this way we have like a double beneficial for the roof itself. You take the seed material, which is native, also genetic diverse, and you also protect the substrate when it's like bare substrate. And so in this way, basically, human is like acting as a dispersal vector, overcoming then the fragmentation, which the seed is, as I mentioned before, is creating in our landscape. But then, of course, the assemblage, the final assemblage of the species, even if we want to bring wild species, wild flora, then the final species assemblage will be, of course, influenced by the local conditions or the city conditions. Just one example about this technique. This was a roof still in Zurich, Technopark, of 1,700 square meters. And in this way, we wanted to improve let's say the condition, the situation. It was sandy gravel, varying from 10 centimeter to 20 centimeter. And because since the worker of the building wanted to produce honey, so bring some honey beehives, then we wanted to bring up there some flowering plants, and we applied this technique.
which means applying fresh hay in September, cut in September. And we collected seeds for 3 months from dry hay. So what about the Mediterranean climate? If you want to bring this kind of knowledge, Swiss-German knowledge in Mediterranean area, first of all, we have to consider that this is nowadays recognized as a standard approach, which is the habitat template approach, which was developed surprisingly at the same time, at the same moment, but in the United States. And for the Mediterranean case, we have some theoretical, let's say, thoughts at the moment. We don't have any practical example, but we have like species list, of course, from habitats that, as we already listened today, are similar to that on the roof. But of course, it depends on which kind of substrate we are using over there. But what I think is also important is the annual aspect. Since I work on green roofs, I always rarely hear the word annuals. That's because the cycle is very short of the species. So normally people tend to prevent the use of annual species, so pterophytes, and prefer to use geophytes as well, are kind of annual cycles, but they still keep on living in the substrate. But the preference then go on chamephytes, so on woody species and perennial species. That's because the idea is to have continuously covered green roof. But as a matter of fact, in the Mediterranean climate, we have more annuals than others. So it's a component which I think we should consider. I want to present here this plant sociological approach. And that's a kind of particular kind of habitat template approach. I'm about to finish. It's kind of, let's say it's easy, because you have like a database of Natura 2000 habitat already done by ecologists. So you have already plenty of habitat which can be easily reproduced on mimic on green roofs. And of course, we cannot use phanerophyte and agrophyte normally. And we should go for, as said before, an hemicryptophyte, chamephyte, geophyte, and pterophyte. Then the habitat should be then, and could be chosen according to the substrate, which I already experienced have been used in Switzerland as a standard, a common substrate. So kind of sandy substrate with gravel, pebbles, and sand, as I mentioned before, and xeric substrate. So actually the soil can be then amended, of course, and doesn't have to be used straight away in this way. So to fit then the normatives, the actual normatives can be anyway amended. And the idea is, of course, as I mentioned before, when we vary the substrate thickness, then we vary also the potentiality of the plants to establish. So the vegetation varies from pioneer species to a mixture, more or less balanced mixture of forbs and grasses. Those are some examples of habitats. I just will go through with pictures, and of course what I think is important, that is clear, is that the habitats, and that's why phytosociological approach or plant sociological approach, what's the idea behind? When you have similar condition, environmental condition, the species composition tend to be the same, or let's say similar. And that's why botanists invented this kind of classification of species characterizing the habitat. So if we consider this species list, basically, so this assemblage of species which are already given by botanists, we could mimic not only the habitat as a model, but also the species composition, which since the species live in nature together, we could be able and should be able to recreate resilient habitat. The same goes for the other habitat I mentioned. I go quick because I want to show some spontaneous roof and some roof in Italy as well. This is in close to Padova, in Fosso. And the seeds, in this roof was used some commercial substrate from a local firma. And the seeds were coming from Magredo. Magredo is a sub-Mediterranean dry grassland of those areas, of Friuli area. In fact, the seeds were developed then and produced in Udine. And this is the nursery. So all these plants comes from mother plants taken in nature. This is another spontaneous roof, and that's referring to topsoil transfer, because I think one of the options is also to use substrate, as of course not as it is. That's the very rough stratigraphy that was used in 1991, so more than 20 years ago, on this roof in Palermo. Of course, it's far away from the standard, which are nowadays recommended, but the roof is still there after 20 years. And as a matter of fact, there is kind of embryonal modern green roof in a way, but still giving. I think it's the only green roof in Palermo, and you can go up on Monte Pellegrino, which is like a hill above the city, and then you see all just concrete jungle, and then you see this kind of this is not Photoshop manipulated. This is just Oxalis pescabre, which is a South African plant growing all over. But then, of course, the dynamic continues, and then you have Poaceae species. In this case, you have Avena barbata, then dominating the roof. Again, cycles. That's the last example. And that's the roof in Manarola, Cinque Terre, Liguria. So still Mediterranean, but with more water availability. This roof is even more extreme, because this was never supposed to be a green roof. Actually, this should have been like a, I don't know, many-story building. But the people living in Manarola, they stopped the construction, and they just left basically the waterproof membrane, or the membrane, just as it was, because they stopped the construction, which was actually illegal. But thanks God, nature is working for us. And then there was like an avalanche, and basically the roof was greened by itself. Then, of course, some people started, just by local people, started to level a bit the substrate and plant some plants. And here you have like a spontaneous biodiverse green roof with different substrate kinds, different substrate thickness, and of course biocenosis. And you have like in a more shaded area, you have ready bushes. And from the Oleoceratonian Alliance, which is, by the way, the maquis, Mediterranean maquis, and also other annual species, including orchids, spontaneously arrived there. So, conclusion. Nature conservation, as I hope I send the message, on green roofs offer new perspectives to urban sustainability. So biodiversity, green roofs constitute actually room for nature above our houses. What is very important is public incentives, building codes, and of course the price has to be reduced in order to spread the technology. From the designer perspective, of course, designer has to have a very strong ecologic base in order to be able to create habitats which are, in a way, merging with the environment. And this kind of new paradigm for landscape architecture have to be supported by scientific knowledge, so applied research. This is just a slide that it's before this morning. This is the same, seems to be the same picture, but it's not the same picture. This is taken just here behind the building of the university, so in the natural reserve. I was crossing this morning from the hotel to arrive here. And this is on the roof, on the green roof in Basel, the one I showed with the valleys and hills. So two completely different habitats, but two mantis praying for something. Probably they are praying that we plan better and greener city. Thanks for the attention.
Good afternoon. I would like to welcome everyone attending today's seminar at the Maltese University. Thank you, Antoine, once again for the invitation, because Antoine Gatt, together with Massimo Valagussa and Alberto Tosca, attended our working group in Poland, and they took part in our meeting concerning climate adaptation plans. So I really would like to thank you for contributing our Polish meeting. First of all, I would like to tell you something about Poland, which is strongly connected with climate change. In terms of our climate, it is defined as transitional, and we can observe that summers are really hot, extremely hot, while winters we may feel that it's sometimes really severe and cold, and there's everlasting snow while you experience in February, for example. So while the average precipitation in Poland is similar to this in Malta, it's around 600 millimeters. In terms of Polish location, we are surrounded from the north by the Baltic Sea. In the south, there are the Tatra Mountains, while in the central part, we've got the great region of lakes. Now, a few words about my hometown, the city of Radom, where the project is implemented. It is located in central Poland, 100 kilometers to the south of Warsaw, which is the capital. The population of my city is over 200,000 of the inhabitants. It's located up in the Milky River. The Polish name is the Mleczna River. And the city is situated at the fork of the Vistula and Pilica rivers. The city is quite old, as it dates back to the early Middle Ages. And there is one of Poland's most environmentally friendly and modern wastewater treatment plants. In terms of logistics, it is a big industrial center, and it is located at the junction of several major transport routes. Of course, it is dominated by the precision engineering and metal and leather industries. In terms of cultural events, this is the city of festivals, ranging from cultural music and film, as you can see, to fashion and international air shows. As far as sport is concerned, we've got two major basketball and volleyball teams. So there are some sports events every year celebrating those winning teams. In terms of the history, there were some labor's protests in June in 1976, which marked the beginning of political transition in Poland. Now, the clue point of my presentation, which is called Adaptation to Climate Change through Sustainable Water Management in Urban Areas in the city of Radom. Project location is, as you can see, marked over here. So this is the situation of Radom and the location. The project started 2 years ago, but still we are dealing with some designing works, and the end of it is marked till the end of 2020. The municipality of Radom that I today represent is the coordinating beneficiary, while we've got 3 other partners. One of them is the municipal waterworks in Radom that are responsible for the technical matters. We've got the Danish partner, FPP Enviro company. This is the think tank company based in Denmark, and the University of Łódź. They are the pioneers in Europe in the field of eco-hydrology. The overall objective of our project is to increase climate resilience in our city by building these green and blue infrastructure. We would like also to control extreme flows of water because of the location that I told you before. It can be done also in terms of improving knowledge for decision makers, because it happens that political parties not necessarily want to include in their election plans matters concerning ecology. The other objective would be raising awareness, not only among our society, adult society, but also among students and students in primary and secondary schools. Of course, it's important just to integrate and enhance biological diversity in all the project actions. This is the city map, and we are to build 6 major investments included in the inner city and the outside city parts. These are the places where the development of those big infrastructure in terms of blue and green infrastructure investments are going to be improved. In a minute you will see a film that promotes our project, and those actions are included in the material, but the major ones include adaptation of sedimentation ponds and building a new weir at the reservoir in the city center. In terms of green infrastructure, we tend to implement swales as we treat them as urban meadows. They are open elements of this infrastructure, and they are shallow and wide channels with different plants and trees. This is the intersection of this, and this is the intersection of a typical swale which is going to be implemented in Radom. We hope to introduce all the elements by the end of this year. So these are the plans that our architects, landscape architects just prepared. You may see that there are a lot of benefits concerning implementing swales. They reduce volume of runoff, reduce speed of stormwater. It's a natural infiltration, and it's also attractive and cost-effective. This is yet another intersection. We decided to implement those swales in the city center because of really hard infrastructure, which has been introduced for many years, and now we are trying to develop a different approach towards urban planning. As far as green roofs are concerned, we have already adopted a vision from Sheffield in the UK. This is the example from the UK. And the City Hall decided to accept the dimensions, the construction of such a bus shelter. Green roofs tolerate well temporary water shortage, especially in summer. We've got some problems in Poland concerning days without any precipitation. That's why there's a need to choose special plants that will manage to survive during droughts. And one of the example here, which is going to be adopted, is sedim mats. They are resistant to drying, and it's quite flat, like 5 centimeters. They can be installed either on the flat surfaces or those with sloping ones. Of course, we've got 2 types of bus shelters. Those that are implemented in the whole city are just like in this previous picture, while the one on the left presents seasonal solution, because we don't need only sedim mats, but we also want some flowers and make our city look more colorful and more aesthetic. We are still considering using high plants because while snowing in winter, it would be really hard to receive the amount of snow. So it would be easier for the cleaning companies to reduce or to clean the shelter from snow while having flat surface. In this case, it would be a problem. apart from this, we need to take into consideration that 12 square meters, which is the total area of the bus shelter in Radom, weighs with 10 centimeters of frozen ice over 1 ton. So reinforced construction is needed. So these could be some seasonal shelters, while the previous picture shows those which are implemented within the whole city, and they are already confirmed. Other solutions that we implemented present permeable paved surfaces. They are not only ideal for pavements, but also can be used on the playing areas, tennis courts. So still they are used in different areas of the city. This is only the showcase in the park. Here there's another intersection showing the solution of three trench system. There are many narrow streets in Radom where every square meter is important both for pedestrians and car users. So we decided to implement this system. Trees can freely grow in areas, in paved areas. In this way, they use the water from the tank situated below the surface, the pavement, and there's no need to shorten the area for cars or for pedestrian zones. There's the place where it was constructed, and here there's yet another example of the square where all those elements of green infrastructure were put together, and there are special rain gardens created near the playing area for kids. They can observe how water circulates in the environment. Of course, there are some permeable pavements just around the whole square. So this is the latest project that is going to be implemented in the next months. Here we decided also to introduce climate schools, starting from kindergartens to secondary schools. Kids will learn how to store stormwater, and they can be later disconnected from water pipes to rain gardens, like here in the picture. And these are the green areas that are going to be used for implementing those actions. Here's yet another example for the secondary school, the same solutions. What about, in terms of project results, I would say it's the most complex view that has ever been adopted in our city, as retention capacity of sedimentation ponds will increase by 10%. Extreme flows that really interfere with transport in Radom in the around the Mleczna River will be increased by 10%. The Borki Reservoir, which is the main city reservoir during the summer, it's especially popular among citizens. Its capacity will be increased by 10%. Again, those purification capacities of sedimentation ponds will be improved by 10% in terms of nitrogen, phosphorus, and iron. Of course, those new innovative solutions concerning sediment biofiltration systems will be applied, and it will be reduced. I mean, nutrients will be reduced by 20% annually. So in terms of total suspended solids, it will be 40%. Those results will increase resilience capacity in the urban area, as well as will help to increase the number of biodiversity, habitat areas in our city. The project was regarded as the winner because of many different approaches that are implemented into it. At UA level, it's the strategy on adaptation to climate change. It's also Water Framework Directive, Habitats Directive and Birds Directive, Green Infrastructure Strategy, as well as at national level. It's so important as it combines all different strategies and policy plans that are to be implemented by 2030. So now we are doing it all together. And the very fresh matter concerning national adaptation plans, 44 major cities in Poland are now preparing their adaptation plans in terms of climate changes. So there's no other similar initiative within the whole European Union. We hope to finish it in 2 years' time, so each city will be prepared for climate change thanks to these adaptation plans. The funding comes from the European Union, so we hope to present it in a full report in 2 years' time.